Oh, what a day! What a lovely day!
Welcome to Flat Earth Debate. I'm your host, Nathan Oakley, and if you're new to this channel or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you would like to support this channel, there is a super chat that runs alongside each of these shows while they're live, and a link in the info box below the video once it's rendered. But most importantly, if you would like to join the discussion, simply mute the page you are currently watching, then click the link in the info box below this video to join the panel and express your views on the shape of the Earth. If you do join, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcome back on the next stream. Please also share the show. Sharing the show obviously increases the live audience, but this in turn increases the chances of a more diverse panel. So please share the show. And one last time, if you're new to the channel or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. Now, we are joined by The Plain Truth, Sleeping Warrior, Ranty Flat Earth, Karen B, Jose, Iron Realm Media, Hillel Finder, and Alan. How are you all doing?
All good.
All good.
I was talking that whole time. Could you guys not hear me that whole time?
Yeah, we
I
did.
was
We
just-
did.
I'm just kidding.
Listen, Nathan, I need to say something that you missed what Hillel said. Hillel said whilst you were speaking, he said, you can't apply perspective to an orthographic view.
Yes, and that's why they've done it that way.
Correct. So he understands the point. He understands that we're demanding that objects get reduced in size because of distance, as a function of distance. What he objects to is applying it orthographically, because you can't have perspective on an orthographic view, to which he's quite right. You can't. What we're saying is we don't want the orthographic view because that's not the real world. We see in perspective view. But because we're presented with the side elevation profile from Metabunk, you have to apply it that way because that's the way that the language is written in your calculator. So it is the case that we want that size reducing, even though it's not orthographically accurate. We accept that it's not. However, it is perspective in the real world, just done on the side view. Do you understand the position now, Hillel?
Oh yes, I understand.
So why is it not done?
Well, some part of the thing is that, like I said, you can calculate angular sizes from an orthographic view.
We're not trying to calculate orthographic sizes, right? What we're trying to do is establish a comparison between that and a photograph.
But you need to calculate.
You're obsessed with the
sizes
orthographic
then, right?
view,
You have to
even though
compare
it's
them.
got a picture of the guy taking the picture, right? So the orthographic view is irrelevant because we're never presenting an orthographic view. We're presenting photography. So why you're so concerned about what Mick West or the standard model makes you do is because you've got a religious belief. You're totally attached to this ball, and however the ball says it should be done, you want to do it that way. The ball says do it orthographically. So how can I get an angular size? I don't care. This is your bullshit calculation.
But you do need to but if you want to apply this angular size thing, you do need to calculate it, and in order to calculate it, you need to use an orthographic view.
We don't care how you calculate it. We just want to see it applied. So do whatever sum you wish, but apply it before you apply the hidden.
But you need to. This is the problem. Is that again, hidden and all these other values? They're all in the orthographic sense, right? So you need to do those first, and then you get and then you can calculate angular sizes from that, and then apply it to whatever it is you're working with.
Well, the hidden can't change, right? The hidden's fixed. It's an absolute.
Well, I guess it depends on exactly. Okay, if you have a set target at a set distance, you have a set height, then yeah, the hidden won't change.
Right. So the hidden's not part of the issue, is it? The hidden is outside of the issue. The only issue is, have you guys considered perspective before applying the hidden value? And the answer is clearly no.
But Anthony, how would you apply perspective before you calculate it?
I'm not the one with the website.
No, Anthony, I'm talking about not actually, but how would that even work? Is my question.
I'll show you. Nathan, share my screen, please. It's simple. On Metabunk Curve Calculator, we have the side profile, the orthographic view. And all you've got to do is reduce the target according to the rules of perspective. And then eventually, when you've got it to the apparent height, then apply the hidden.
Yep. I think we've already gone over that. This angular size, again, it's going to calculate in an angle. It's not going to calculate in a distance.
Ah, then you're using the wrong maths, aren't you?
But no, that's the only way to do it.
No, it's not.
We've gone over this before. Angular size
Well,
is an
that's not
angle.
my problem. That's your problem.
And again, this is not something that is expressly about the curve of the Earth. This is just something
course
about
it is.
math.
It's a curve calculator.
Are we talking about a curve
No, forget about-
calculator?
no, we're
What
just
the hell are you talking about?
not-
We are
not
literally talking about a curve
for a moment.
calculator.
It's just talking about calculating the concept of calculating an angular size as a
Well,
distance. That's not
No,
necessarily
we're
about the
talking
curve of the Earth.
specifically about curve calculators. The fallacious begging the question calculations you use to prove that the Earth is a sphere when comparing to photographs. That's what we're talking about.
Well,
And I'm talking about the concept of calculating an angular size at
Well, you're talking about the wrong thing, because we're talking about the application of angular size to a curve calculator.
and let me just say this: if you're going to say about, oh well, it's an angle, it's not whatever you were going to say, whatever your argument was.
It's not a length, it's an angle.
I saw Reds demanding that people accept that they've told us about this 2-arc tan sum that he demands is the maths. However, that conflicts with what Mick West told me was the maths. So on the one hand, we've got Reds beating about this 2-arc tan and then the application of this formula. But on the other hand, we have Mick West that says that this is the maths. And to be honest, I don't care what the maths is.
Those are the same thing.
Well, they're not, because one doesn't have an arctan calculation in it, the other one does.
Actually,
So
what
they're
is-
not the
let
same
me
thing.
actually take a look at what is this?
This formula is basically the actual height divided by the distance and then multiplied by the focal length of the camera. That's all it is, which is a minuscule adjustment. So you can basically get the apparent height by, this would be the actual height because it's the capital Y. This is the total length because it's the capital Z. And then you can work out the height reduction over distance to give you the Y value, the lowercase y. But it's basically the actual height divided by the actual distance. Now, this came from Mick West. I'm not saying this is right. I don't care if it's right, but it's not the same formula that Reds was talking about. So we're at a conflict. We're getting told by Mick it's one, Reds it's another. And like I say, I don't care which is right. What I'm saying is we want something applying to it because objects do get smaller over distance.
Are you sure that they conflict?
Yeah, because this says distance, absolute height divided by distance multiplied by the focal length. And then when we go back to Red's Rhetorics one, which is what he talks about, is to get the angle, it equals 2-arc tan, and then you have the whatever the value of G is, I can't remember what these are, divided by 2R.
G
So-
G is the actual size of the G is the actual size of the object,
And what's
and
2R?
R is what?
What's 2R?
R is the distance to the object.
So doubling the distance so what you're saying is the absolute height divided by double the distance.
Yeah, that's how you calculate. That's the law of perspective.
And then 2-arc tan being right. So that's not the same formula then, is it?
But have you tried them both in the same circumstances?
It's not our calculator. We're waiting to see you apply it, for God's sake. How many times do we have to say this? This is not our problem.
Yeah. Red's
Well,
one gives you an angle. This one gives you the value of y, which is the height relative to the distance.
And we couldn't give a crap about either. All we want to see is you apply it, and when you apply it and present it to us, we'll scrutinise it.
Because I'm sure you'll get it wrong. And do
Wait,
you know
Right.
when
why
you say
you'll get
apply it,
wrong?
I just want to make sure we're talking on the same grounds here. When you say apply it, you mean compare the output of the calculation to
No, a comparison is not an application. You're comparing to the photograph.
So what do you mean if not use, then what do you mean by apply?
Account
Let me help.
for the angular size reduction at distance and then calculate how much bullshit curve you think should be there.
Oh, all this time you were saying apply it. I thought you meant you actually do the calculation and then
No, I'm not asking you to just calculate it and present it to me. No, that's not what I'm asking. I'm asking you to take into account the fact that objects in the distance appear smaller and objects in the near foreground appear bigger. Simple. Perspective. Apply it.
Hillel, let me show you in real world. Let's say we've got a 1,000-foot mountain and we're viewing it at 30 miles away. So when we put it in 30 miles, and this is what Al-Kay did, he did one at 38 miles, and this is where it came. This is how I got it. It gives you a value of 452 feet refracted hidden. So when you have the line going down, you can see the refracted hidden is the dotted line that goes here called hidden. However, the mountain that he's looking at is the hidden value is being applied against the full height of the mountain at 1,100 feet. So when we go back to this picture, which would be this one, what we're saying is, let's get back to, where is it? Bear with me. Drop that down. It won't let me swap over until I get it. So when we're saying with regards to the mountain at 30 miles, what we're saying is, come on. What we're saying is, we know that mountains get smaller, apparently, apparent size over distance. So what we're saying is we want the mountain reducing in size over distance, the 30 miles, so that the 1,000 mountain is still 1,000 feet, but it's got an apparent size after 30 miles, because 1,000 feet is not the same as 1,000 feet at 30 miles. So what we want to know is, with a 1,000-foot mountain at 30 miles, what's the apparent size? I don't care how you get there, just give us the apparent size at 30 miles, because I know it's a couple of dots on the horizon. Everybody that's done any observations knows it's tiny. It's not 1,000 foot. It's 1,000 foot at 30 miles. Then you can apply the hidden to it. See what the hidden value is. And guess what? That hidden value of 452 feet is probably going to be about 10 times bigger than the apparent size you've calculated for. That's where the problem lies. Do you understand?
I understand what you want, but I just want to say that you want to apply the hidden value which is like I said, an actual value, and you want to apply that to
how many times? Right, the hidden is based on the bulge. That's your target in the near foreground. We don't ever see a bulge. We often see refraction counted as obstruction, but you have got a bulge. That's what you assert in this bullshit. So you need to account for the angular size of that bulge.
So Hillel, so this is what's going on. These guys, Ranty, Anthony, they present photographic evidence, really good evidence, which is a flat earth evidence, every single one of them. Now, you say, what do we want? We don't want, we don't want anything. What you want is explain what we're looking at. You want to say it's curvature and you want to explain it with math, with numbers. You want to throw a calculator in it. We don't care about that now. If you are using a calculator to say the word we're seeing with numbers, now you got to apply the math right. We're telling you it's wrong because you are leaving out the perspective, which is the reality of everybody. So if you want to explain the observations with math, do it right. What do we want? We want you to be honest and use the numbers right. That's all we want.
Yeah, the problem is the numbers are being used to deceive people, and the deception is based on them excluding perspective.
It's only a perception if you don't know how to calculate angular size.
I don't need to calculate anything when I take a picture of something. You are doing calculations. We haven't got a calculator for curve Earth now, do we? Yes or no?
We don't have a calculator for curve Earth?
No, surprisingly, flat earthers don't have a curve calculator. What do you know?
Oh, by we, I missed it.
Yeah, by we, I mean I'm a flat earther and I don't have a presuppositional value of R, and I don't try and convince the world that what they obviously see as flat is curved when all we actually observe is perspective. You say the world is curved with a calculator that assumes R, and you exclude perspective. Don't ever ask me how to calculate perspective because I don't care. I know it's real and I know you exclude it.
Amen.
Lots of long silences when we assert these things, eh, Hillel? Just you pondering how to get around what I've just said? Or are you going to reply, yeah, you're right, perspective is real, we should really account for it? No, just silence. Oh, he's gone. What a shock.
He felt the heat in the toes. He knew they were going to the fire, so he rage quit.
It's funny because it's like, maybe you're realizing that your photograph doesn't match the globe model. Are you realizing that? That what you see
The penny
doesn't
might have
match?
just dropped. The penny might have just dropped, and he's run off to cry for a little bit. Bring it. He wants his ball back. He's begging for his ball back.
Nobody likes it when you take their ball away.
That's all this is. Fighting it. We must use side elevation. We must. How do we get it from orthographic? I don't care. This isn't my problem. You have got a ball belief. You have got a presupposition. You are telling the world that it is a ball, and we're all outraged about it. So we've started having a damn good look at it, and what do you know? It's riddled with flaws. In this case, perspective is ignored.
And the explanation they have is math, numbers, very, very fancy equations. But then when you discover the trick, when you discover the magic trick, which is avoiding perspective, then they don't know what to do. Oh shit, we don't want to explain no more with numbers. So let me see what we do, because evidence is not there as a picture.
Or they'll try and do what he did, which is say, look, I'll either calculate perspective correctly and then just completely ignore it and say, look, I can calculate perspective. And it compares to the maths, which is our point. We only have perspective, but they'll compare it, thinking we won't notice. Or they'll extract out some angular size measurements from their calculation and then say, oh, well, there you go. I can calculate an angular size. Look, I've managed to extract the actual size. And look, it matches Wiki. Let's go back to using actual sizes because that makes sense. And they think we won't spot this garbage. Like, we haven't all been intensely looking at it the same as them. But we're looking at the flaws and saying, how can they get around it? While they're going, how can we get around this?
So what happened to Hillel? I went down to make a brew, come back up, and he's gone.
I asked him a difficult question. So he went.
Did he leave?
Yeah.
He left?
Left of his own volition, like they all do when they have their toes held to the fire.
He's trying to join. He sent me a message saying he can't get back into the hangout.
Maybe he didn't drop. Maybe it was network error or something. No one kicked him. There was no trolls.
He's saying he got kicked in the chat.
Oh, he's lying.
Well,
Because
let's
no one
just
kicked
check. I could check to see whether he got kicked or not.
Yeah, you check. The only one that
Did
would have
Hillel
done it
get
would have been
kicked?
Alan B.
Oh, we did. Alan B removed him.
Did he?
Alan B kicked him.
Alan B
Bastard.
removed Hillel. Why did you do that, Alan B?
Alan B.
Wow, what a
That's
moron.
because Alan B was being told by Rumpus, don't let this continue. It looks really bad.
All right, so we've got a baller that removed a baller. This is wait. What do we deduce from this then, eh?
Wow, this is a turn up. Don't let us look bad. Best to get the globe head out because he's conceding things we definitely don't want
So
conceding
come
here.
on, let's ask Alan B. Why did he remove Hillel?
Can't see him in the chat.
Oh, has he
Interesting
left?
turn of events.
Yeah, I think he left. Yeah, he kicked and he left.
He kicked
No,
and
I was
left,
incorrect, M.
right.
Scott Veach. I'll take it back. I'm not a liar. Your father's the liar. No need to project this onto me. I was incorrect. Somebody did remove him, but what I asserted was no trolls joined in us and removed him, which was correct. So I'm not a liar, M. Scott Veach. That would be your dad.
And can I just let everybody know that I removed PMARS because I didn't want PMARS to remove Hillel whilst Hillel was being grilled, not thinking that the risk is actually going to be manifested by Alan B. So shout out to Alan B. You caught me off guard there. I mean,
And he
that's
was
how-
listening in science. Alan B was listening in science. He didn't say a word all whole show.
That's terrible, isn't it? That a baller removed a baller and it wasn't PMARS.
You do realise, though, that without him speaking, he'll deny that it was him.
They
don't
are
care what
already.
it's
Can you
nice.
show it, please? Because it's say I've got somebody in the chat already. Nathan Oakley, 1980. Can you show that it was Alan that removed Hillel? Yeah,
I
I'm sure
certainly
we can
can.
show that.
Nath, do you want to share my screen?
Yeah, I see it in the back chat. There you go.
So we got Pete Southland joined the hangout. Ranty Flat Earth removed Pete Southland from the hangout. Alan B removed Hillel Finder from the hangout. And then Cult Exposer, he's just joined, and that's him removed. That's how it's done. So black and white, it was shown that Alan B removed Hillel Finder. It tells a lot, doesn't it, when a baller removes the ball?
Now it's time to troll us because this looks bad as well. They've all just said, nah, that's not the case. A baller wouldn't remove a baller. No way, no way. And then we've shown it. And they've gone, quick, send 1 million trolls in. Get them all out.
The sleeping warrior left or he got kicked?
I think he got kicked. I think he got sniped by that FE cult. But that's
So-
all right.
That the only resource they have to kick people, to troll.
Gonna have to grab him, Nath.
It's all right. I'm sure the first 20 minutes of the show can definitely get mirrored because they were very damaging. You know, all that's just happened will not be negated by just a constant stream of trolls. Oh, but it does look like they've removed the 90% of the guests.
It's very telling, though, isn't it? The behaviour. It speaks volumes in itself.
Just get Anthony and Ranty back on Skype. Give me a moment, guys. Oh, no, the whole hangout's been kicked. There will be a short intermission. Welcome to the show where you don't know. That's right, we had the snipers in. Should be the work of but a moment. Right, let's get this link out to a few people on Skype. We will have a closed hangout temporarily. A big boss and masturbators. There you all go. Have a bit of that. Hopefully we'll get our guest list back. Minus the people who are sick of it. Hey Anthony, good to have you back.
Yo. Did you see that it was Allenby that removed everybody? Removed Hillel?
Yes, it got on screen.
Good. I managed to get sniped whilst showing that.
What a surprise.
It was incredible timing to be able to do that. I actually thought that it was I'd done it because I saw him join, flicked back to it and removed him, but he'd obviously got to me first. But it says a lot when Alan B. It must be the case that Alan B was told by somebody to remove Hillel because Alan doesn't kick people. I don't think I've ever seen him kick anyone before.
Yeah, it was pretty damaging to their cause, to be fair. They had to take him out somehow. He wasn't going to leave of his own free will. So we weren't going to kick him because he was getting slaughtered. So
it must have been Alan B's account that was kicking people because he was the only one that was in the list and he'd already kicked Hillel. So I left him in there not thinking about it, but it must have been him that kicked everybody. Because there wasn't anybody else in there that could have done.
Nah, we had an influx of trolls.
Exposure, wasn't it?
We had an influx of trolls at that particular point. So after that had happened and you started showing that it was actually Alan B that had removed him, then we had a massive influx of trolls.
Hillel Finders asked me to show the formula that he sent to me. Although I'm not going to show it, it's like basically text. It's really text heavy, and basically it's the third formula for perspective. So now we have three. We have Hillel Finder's perspective formula. We have Mick West's formula, and we have Red's Rhetoric's 2 out of 10 formula. So again, this is not our problem, and I don't care what the maths is. It's for you guys to work out. But let's be clear: we'd like to see the target reducing in height over distance before you apply the hidden value to the said target, because that hidden value is an absolute. It can't be changed. It's not subject to perspective, because the hidden, by virtue of the fact it's hidden, is outside of perspective because it's not seen. So that you have an absolute value of the hidden value, whatever that value is. And then we have the target, whatever that height is, reducing over distance. Then you apply the hidden value to it once you've reduced its angular size. So we don't care what the math is. We just want to see somebody doing it honestly, because if it's okay for you guys to adjust for refraction, then you damn well can adjust for perspective as well, gents.
Yeah, there's so much burden of proof reversal going on. People constantly saying, well, do you know perspective? It's like, We're all looking at perspective at the moment, but as soon as we say, yes, we do, they'll say, well, how do you do it? It's like, I don't want to apply anything to your calculation. Yeah? How much we're studying perspective now is far more than I ever thought I ever would ever. But I'm not going to give them anything or tell them that I need to apply anything to anything, because we don't. This is not our problem.
Correct. Yeah, Nathan, if I share my screen again, I just want to summarize Hillel's point. Because he did get this. And this is the bit that destroys their position, really. Hillel said you can't apply perspective to an orthographic side view. And he's quite right if you're going to maintain that it's an orthographic view. But we're not trying to maintain that it's an orthographic view. We're trying to say that you've got it represented this way on Metabunk. And this is the way to demonstrate our point that you guys must implement this, however that may be. So targets reduce over height over distance. Then you apply the hidden. That's it. That's what we want to see, because that's the real world. Don't care whether it satisfies the definition of orthography or not. We accept that it doesn't. But we're trying to make the point so that people like Sean don't misrepresent my point and then have a 3-hour hangout based on a fallacious, nonsensical tangent that wasn't made. He doesn't understand my point, or whatever he did. I don't understand what he did, but he had a 3-hour hangout based on it, and it was wrong. So I thought people got this. It seems that flat earthers are getting it now, but it seems that the ball earthers are still struggling with it, and Hillel is clearly one. Yes, you can have an orthographic view and show perspective, because we're not trying to maintain the orthographic view. We're just trying to demonstrate the point that targets in the distance will shrink. Then you can apply the hidden to it. Till you do that, you guys don't have an accurate, well, it's not even close anyway. It's nonsense, because
I've got to stop you, Anthony.
We'll
I really have, because you're just going to get people criticising what you've just said. You can't have perspective in an orthographic view, because the two are mutually exclusive. Orthographic.
Yeah, but we're not trying to preserve the orthographic view.
Yes, that I will agree with. If they want to preserve their orthographic view, then they've got a very real problem. And Hillel said this as well. Well, you're talking about angles. Yeah, absolutely correct. Your calculation needs to be based on the angles. Because as soon as you put those angles in, i.e. low angles, not a straight line from eye to target, you'll find that they're intersected by the bulge that isn't there. And suddenly the maths will go wrong. So that's why they exclude perspective and do it orthographically, because it nicely compares to perspective. The false curve that they engineer, the world they say we live on, is based on space from the air, total nonsense that we can't do from NASA, CGI rubbish that they give us, and the ground defense for this bullshit is the curve calculations, the standard model, the assumption of R. It's all they've got. So with us saying, well, actually, no, you have got just perspective at play here. No. We do it in orthographic. You can't get perspective from orthographic. It doesn't work like that. You imagine if you're looking at a side elevation of a house. It's like, what do you mean imagine if we're looking at a side elevation of a house? We don't. We look at pictures, and they all have a perspective in them without trying, without calculating a damn thing. And that is what you're comparing to without accounting for perspective, because you say, well, if we look at a side elevation of a house, like somebody's come along with blueprints and said, can you work out the curve on this blueprint? No, nobody does that. They come with perspective inclusive pictures every single time. What do you know? But yeah, here we go. You're showing us side elevations. This is how you've done your magic trick. And the more we say it, the more it'll become obvious to people how they've done the trick. You just repackage the observation from a completely different point of view that ignores perspective. And Bob's your uncle. Perspective ignored, curve achieved.
Karen, can I just ask if you get the point that we're trying to make?
Yes, I do get it.
Do you agree?
I do.
Cool. That was easy. Why can't Hillel Finder do that? I think he's a physics undergrad. Might be wrong, don't quote me on it, but I think he's doing physics at degree level. If Karen gets it and Dawn try to get it, why does Hillel not get it? Why is there such an obstruction to this point being applied?
Because
the answer, of course, is it destroys all
obstruction.
observations in future, because it'll never match the curve calculator.
Yeah, the obstruction is the obstruction. That's the problem. The bulge. As soon as you start drawing lines to the bottom of targets to calculate how much they're obscured, you'll find that the whole bloody thing's probably gone, because the bulge is at 1.5 miles in a 30-mile observation.
Yeah, we haven't even got to the horizon. I mean, if you do a 30-mile observation on Metabunk curve calculator, it tells you the horizon's less than 2 miles away. Yet we all know that the bulge is halfway between you and the target. So why is that? The horizon is supposed to be the bulge on your model, yet it's like 5% of the distance away. That's because the geometry dictates that that's what it must be. It's amazing that nobody's spotted that before now. And shout out to all those, particularly Taboo Conspiracy, because he's been doing horizon tests recently. You guys are mad. You guys accept something that doesn't agree. Sorry, you guys accept something that makes no logical sense whatsoever and can't see the problems with it.
If you get the chance to share my screen, Nath.
Oh, hang on. Let's get Hillel back in. He just said, I didn't realize there was a new hangout. I'd forgotten that. Right, so Hillel Finder, he's just said, no offense, but I'm off. Not being able to defend my own words and positions, I don't see much point sticking around. Sorry, I'll come on again tomorrow when I can join the show. Well, he has the link. He can join the show again now. Rejoin. I'd forgotten he was in the background. Sorry, Ranty, go on.
Yeah, am I sharing? You there, Nath?
Yeah,
You're
sorry, I
sharing,
turned
but-
myself on mute rather than off mute. Yes, you are sharing.
Right, okay. So we were talking about this before, and essentially what we're trying to do is ask Hillel to do something similar to this, which is you take a photograph, you get an observation, and then you work out the curve calcs on that using perspective. Now, fortunately, I already did this with Nate. Well, I did it on a live stream of mine as I was preparing to go on Nathan's show, I think a couple of Sundays back. This was the results of that work. It was done live, and essentially I took the hubs of the turbines and I ran a line directly through them. I calculated where prospectively the angular size change would have meant that they would have met the apparent horizon, which would have been at 22.34 miles. Coincidentally, this exact distance was the same as the curve calculators, and yet it was due to perspective rather than the curve calcs, because this line ran directly through the center of the hubs. And this is what we're trying to say. We're trying to say that prospectively, these would have reduced in size at 22.34 miles to a pixel. They would have disappeared. They'd have been at the size of a pixel at that distance. So when you apply curvature to that after doing this reduction, then it doesn't work. It doesn't work on the globe Earth model at all. It only works prospectively.
Right, I've just dug out the pictures, Ranty, so I'm going to share my screen now that you've shown that, and then I'll make a little concluding point at the end. But so what we've got up now is these wind turbines demonstrating beautifully what was the formerly known as curvature. So they're getting smaller into the distance. However, when you see them inside profile, they are definitely not built on any curve. They are flat as a pancake, all built on the same level ground locally to each other because they're not that far apart. Whereas coincidentally, when you put them into the curve calcs, it says these things are built on a curve. They're curving around the Earth, and they definitely aren't. So what we know from this is that we do definitely have the effects of perspective. You would expect them to get smaller into the distance in this photograph, even though they're only a quarter of a mile apart or an eighth of a mile apart. So they're not curving, they're definitely flat. This view is the side elevation of those same wind turbines. But when you see them at an angle, you can start calculating out how much they are dropping. And again, you don't see curve, you see an angular size reduction at distance. And in the Ranty picture, if you can just pop that picture up that you had a second ago, Ranty. In the picture that Ranty's demonstrating, he's only calculating perspective. So nothing more than perspective is when Ranty's got it up. There we go. So in this picture, all Ranty is accounting for is the angular size reduction at distance. So what we're saying is, well, guess what happens when you add the curve to this? Yeah, it's more gone than it already is. So the last one that's supposed to be a little bit gone or a little bit visible because of perspective and angular size reduction at distance, when you add into this the engineered bullshit curve they say we live on, obviously it's all gone.
And in addition, it seems to be the case that anything above 20 something miles, 22, 23, 24 miles, once you get to that distance, the angular size is so small, but the hidden value is so big relative to the angular size reduction that it swallows it up completely. And in real world, if we lived on a sphere, that would be the sphere, that would be the curve, and these objects wouldn't exist in the picture. But of course, we're all getting pictures that show things like the Chicago skyline, the Toronto skyline, and these things shouldn't exist because of that thing called curvature that isn't being accounted for in the maths by ignoring the perspective effect that we all observe. Hilal's
Oh,
back in.
hey, Ranty, do you know which wind turbine, what's the term, collection that was part of?
Yeah, this on this particular one, it was it's the one past Barrow. Let me bring it up on my Google Earth. One sec.
Yeah, the reason I ask is just because I was in UK recently, and I had a similar thing where I looked at some wind turbines that I'm not sure how far away. I'm just wondering if it's the same set.
Here we go. It was these turbines in the distance, so it would have been Ormond. So I was essentially looking through these turbines, Barrow in the foreground,
Oh,
and
I
in the
see.
background was Ormond. There was my observation point was down here, and essentially I was focusing on. Oh, actually, no, I was focusing on Barrow. Actually, my mistake. This is the Barrow turbine. So this row was the ones that I was focusing on, and essentially the angular size change of them made that at this point here, where I've ran this line through Ormondy, is where they would have disappeared due to angular size as opposed to the curve, which coincidentally matched the curve calcs, funnily enough.
And actually, could you go down actually and find the turbines that I was looking at? They're southwest of Southport, kind of near Liverpool, I think.
Southwest of Southport.
Yeah, sorry. They're pretty much, they should be roughly due south of Blackpool.
So yeah,
there.
okay. So you've got the big ones,
I think.
The largest ones, either the biggest ones in the world, I believe, the Burbo Bank extension.
Yeah, it might have been that. I'm not sure.
I think they're about 600 feet high, so they're massive. Them ones.
Yeah, actually, would you mind? Where'd you get those maps with the
C4
with the
Global
individual wind turbines on them?
Well, if you go to the C4 Global offshore wind farm database, it gives you an image of all the turbines, and you can crop them out, and you can put the GPS locations on Google Earth by uploading the image into Google Earth. And that's how I was able to plot all these on here.
All right, nice.
I'll
look for that. Or actually, if you have that on hand, if you could send that to me, that'd be actually great. Save me a bit of time.
Yeah, sure. But awesome. Yeah, so going back to this point, these were the turbines that I was concentrating on, and as you can see, I'm looking at them in this direction across this line. So although they appear in the image as they're going from left to right, I'm actually looking down them. So the one on the right would be the nearest one, and the one on the left is the furthest one away. And obviously, angular size says they would have terminated or been imperceivable at this line here, 22.34 miles away.
The question is, I mean, I've got this presented on the screen now from the sort of 90-degree two observations Ranty made. This is a prior observation, not the one he was just detailing. But we obviously have them going further into the distance and decreasing in size in this picture right now, and that is definitely calculable with angular size because they are so close together. It's not the effect of curvature that we're seeing, but because it's at distance on this axis, we are continually told that what we are seeing here is the effects of curvature when you see it in the effect of the obstruction increasing, i.e. you're seeing less of the turbine at the back than you are at the front, which is nonsense. It's just going through an angular size reduction at distance, something that has continually been ignored. However, when you go to the side elevation of this picture, we know for certain that it isn't curving. It definitely isn't curving away from us. So we're left with, it can only be an optical effect that is being achieved through the angular size reduction at distance. But you don't have to go back far in the debates to find people telling you that these turbines getting closer to the horizon through an angular size reduction at distance is the curve of the Earth. And it isn't. Because, as you can see in this picture, these things aren't curving. They are absolutely flat. And what we do see with the various different coloured lines that are running through them is that, what do you know, the ones that are further back into the distance look like they should have more obstruction when you calculate the absolute size of one of those wind turbines, because you don't account for the fact that it's reduced in angular size. And this is our point. None of this stuff is built on a curve because we don't live on a curve. What you see and call curve is those turbines falling away with an angular size reduction. And they don't. We're not living on a curve. This is what the world is. What we're seeing now is the flat plane that they build on. And we know they build on flat planes. Everything gets leveled out. It's all flat. You're leveling your transits when you're using your equipment to build things. So we are dealing with a flat plane. There's no two ways about it. And this picture proves that you have co-opted angular size reduction at distance, because these things aren't on a curve, but they still get smaller into the distance, and you've just called it curve. Because when you calculate out with the curve calculator how much those wind turbines should be dropping behind the curve of the Earth, it matches. But it doesn't include perspective. We know that for a fact. So which is true? Is it true that these things are really curving when we see them down the x-axis? No, they're not curving. We can see it right now. This is the x-axis taken from 90 degrees. So we're looking along the x-axis when we were looking at them down the line when they were all in front of each other. So these things aren't curving. But the amount of time somebody would put this picture on screen and say, that's the curve of the Earth right there. Let's calculate how much of the absolute size is obstructed by Earth curve and get us looking at the horizon, which I haven't even included in this picture. So no bullshit from any globers. There's no hidden value to start bullshitting about. All we're seeing on screen right now is an angular size reduction at distance. That's all this is. They get smaller into the distance. But this isn't accounted for. It's excluded, because that's all it is. Because that's all curve is. Curve is the angular size reduction at distance. It's not curve. It's perspective.
Can I just give a plug to that presentation that I did? It's called Flat Earth Perspective versus Curvature Presentation. It's a mirror, and it's on my channel, Ranty Flat Earth. So if you want to spend 11 minutes looking at that, I go through exactly what Nathan said with a little more mathematics in it, so that you can see how we come to this conclusion.
So Nathan, now that Hillel Fender's back in, without going back into it in too deep, because if Karen gets it and Dawn Treader gets it, I think we should assume that Hillel Fender also gets it. But perhaps we should conclude the point with Hillel so that we can make it concise for him.
Sure, why not? Oh, and thanks for taking me back, by the way.
No worries.
Did you know why you got ejected?
It's possible it might have been a fake Alan B, because, like somebody said in the chat, he always joins with a "Hello, boys."
That's true.
And he didn't this time.
That's true. So we will rescind that it is definitely Alan B. We don't know that for certain. So our bad, Alan.
Yeah, I got really confused because Nathan, you were giving me your spiel, and all of a sudden everything just stopped.
Sorry.
I was like, Nathan probably didn't just stop talking.
You
and the screen stopped moving, and everyone just shut down.
We think it's either Alan B being quiet enough so he can deny it's him, or a fake Alan B. We don't know, so we can't really say it's Alan. It's not fair to.
Just to respond to Jamie Thompson, to be honest, Karen thinks that Bigfoot is real, so she doesn't exactly have issues believing anything. There's more truth in Bigfoot than there is in curvature. That's the reality. You might as well believe in Father Christmas or Bigfoot than you will if you're going to believe in curvature. Because
there's more proof of Bigfoot, to be fair.
Well, there is evidence of Bigfoot, apparently.
That's an obfuscation tactic. All that's designed to do is the same as asking Arwin if the sun is metaphysical, because they know that it's something that they can distract from the very strong point that we're currently making about perspective being curvature. They are one and the same thing. Only one can be real. Curvature is fake. Curvature doesn't exist. Neither do your pictures of Earth from space. The Earth is not a sphere. The Earth has no curvature. The Earth is flat. And we only see perspective, something that is absolutely, unequivocally ignored in the begging the question, proof of nothing, perspective omitting curve calculations.
Oh, also, by the way, Nathan, I suppose you and Branty both think that, the wind turbines in that example, they're only getting smaller. They're not actually, going down at all, right? They're not actually being lowered artificially by any curve of the Earth, right?
Maybe you could calculate that. Maybe you could calculate it with the angular size reduction included.
Well, you're saying only one has happened. Like it's only reducing an angular size. It's not going, actually going down. Like
sorry, are you going to? Sorry, hold on. Are you going to deny that it is reducing in angular size now? Do you deny that is occurring?
I said that is happening, and I'm saying you don't think the other thing is also happening in addition.
So we have a conflict The curve calculator, when you look down this z-axis, keep getting that wrong, y is going up. So when you look down the z-axis and you calculate with your begging the question, proof of nothing, perspective omitting calculator, it happens to match the observation, even though it is a begging the question, proof of nothing, perspective omitting calculation. However, when you calculate perspective, it also comes out with the same result. Therefore, only one can be true. We definitely encounter perspective, but I wouldn't have a show if we definitely encountered curvature.
So then, Ranty, what do you think?
Well, I think you've got enough evidence. Well, you've got enough information from me to perhaps do some research of your own. You've got some images of those turbines, and perhaps you could put a little presentation together like I did.
Yeah, that's actually what I'm working on. Part of the, and sorry, that's part of the reason why I came today is because I also I not only wanted to talk about the perspective thing, I also wanted to talk about that what do you think should be seen sort of thing. So, like, for example, like I said, I went to the UK recently. I went to St. Bees. I looked at the Isle of Man. I also happened to see, not from the St. Bees, but I looked at I saw the Blackpool Tower. I saw some wind turbines, etc. And I just wanted to talk about like a little bit about what you would expect.
Hang on, did you just say you saw Blackpool Tower from St. Bees?
No, I went to Blackpool and I saw the Blackpool Tower.
Right.
Yeah, I didn't see it from St. Bees.
Was it big when you got to it?
Oh, it was very big.
And I'm being dead serious.
It's a very nice tower.
But was it
Lovely.
big?
It's actually my favorite part of the city.
Was it large?
Oh, tremendous.
Right. So when you were standing right next to it, it was big. What do you think happens when it gets far away?
Oh, it became smaller.
Oh, right. Why don't you account for that in your calculations?
Because it's not necessarily necessary.
Not necessarily necessary to
necessary.
account for what you've just seen and described with your own two eyes. So you are literally saying it is unnecessary to include the function of that tower being big when you're near it and small when it's far away. That's not necessary. Why would that not be necessary?
Unless you're going to actually be measuring it or calculating it with...
Oh, what? Like, you calculate it on the curve calculator, you mean? That sort of calculation. Well, that would be a calculation, would it not?
Nathan, let me finish, please. Unless you're actually going to be measuring angles with your image that you get back, unless you take one axis and say, okay, the field of view is this far across, and then measure angles inside of it. Unless you do that, you don't need to calculate
measuring it when we apply the hidden value.
Sorry, what he's saying is, unless you measure for perspective, you don't need to measure for perspective. Is that what you're saying?
No, just angles. Unless
yeah,
you're going
angles
to be
would give you the angular size now, wouldn't it? That's what we're talking about. Something that your calculator doesn't do. Your calculator doesn't do angles, does it? So what you're saying is, if you wanted to calculate for the angles, or as I phrase it, the angular size reduction at distance, you would need a calculator that could do angles, correct?
Yes.
Excellent. Why doesn't your calculator do angles? Why does it only do absolute sizes?
Because it's not meant to do that thing I said about, if you have an image and you measure angles inside of it.
It's not doing perspective.
No, it's not doing angles.
No, it's not doing perspective because angles, the angular size reduction at distance, is perspective.
No, it's not doing perspective.
Right, we understand why it is. We get it. I know it's not doing it. I'm saying, why isn't it doing it? We do encounter perspective. Don't tell me it's not doing it. Tell me why it isn't.
Well, he said it was because it's not absolutely necessary.
Well, yeah, why isn't it absolutely necessary to take into account something we absolutely encounter? Oh, it's got a bit of it easy on.
Sec.
Yeah, one sec, because toast to the fire, time for a bit of a break. Of course, there's an urgent phone call when I ask him why it's necessary to include perspective. The critical question, the question that everybody's asking, or will be by the time we ask it 400 more times to Globers that seem to go on mute when we ask them this question. Why is it not necessary to include perspective, something we absolutely encounter every single time we look at something, every single time we photograph something, and every time we video record something? Why would it not be necessary to include that function, which we absolutely encounter, Hillel?
But he's not back yet, but just in that same vein, if it's acceptable to adjust for a presuppositional R value in addition to bendy light that doesn't even happen, it's damn reasonable that you should be adjusting for something that does happen.
And I just want to address a comment that a lot of the ballers make, which is, if we live on a flat plane, how come we can't see France from America? Yeah. Well,
opacity, the atmosphere,
and the angular size reduction. Because if you had a mountain and its angular size was reduced and reduced and reduced, it would be a pixel at 100 miles. A pixel. You wouldn't be able to identify anything. At 200 miles, it would be completely invisible. You wouldn't be able to see it.
Precisely. Because of the angular size reduction at distance, because you globe heads think you see things in absolute sizes, you think you can see all the way to Europe, because Europe's big enough to see with a straight line of sight on a flat plane. Oh no, well, unfortunately you have an angular size reduction. Not only that, you can see on screen right now that this is a solid piece of rock. It's land, yet it looks like the sky. It's almost opaque because of the atmospheric interference between you and the target. These things look nice and thick and black because they're nice and close. This is much farther away, therefore more atmosphere blocks it, therefore it looks more like the sky than these do. That's atmospheric opacity, and you can't see through infinite atmosphere. Not only that, as Ranty's just addressed, the very point of the shows at the moment is that you do not account for the angular size reduction at distance. Over vast distances, things do disappear because we do have a vanishing point because of perspective, something omitted from the orthographic, begging the question, proof of nothing, perspective omitting curve calculator.
Nathan, can I just say that we can only just about remember the slightly looming non-standard refraction hyena, but we've got no chance of remembering that one.
Well, if you can't remember the proof of nothing, begging the question...
That's an interesting image you have there on screen.
Oh, really? Are you going to assert because there's a horizon there that suddenly we can use that horizon as an obstruction of a bulge that you don't account for its angular size in the near foreground?
No, because this is similar to what I saw, where the turbines are not only getting smaller, but they're also dipping.
Yeah, but do you understand what the point of this particular picture is?
Well, I got the point. I got the part about the atmosphere. But
the mountain in the background is Snaefell.
Oh, is it?
It should be all behind the curves, Hillel.
Well, okay, I'm not going to speak to that at the moment because I don't know any of the distances or anything involved. I'm just looking at the image.
It's a fact that Snaefell should be behind the curve of the Earth in full.
But do you acknowledge that the turbines are not only getting smaller, but they're also going down?
So let's cherry pick from the evidence, and we'll go with the one that supports curve, and we'll ignore the one that completely shits all over it.
It doesn't support curve. It supports an angular size reduction at distance. You also have the effect of mirages that bring up the horizon level. We know we don't have an actual horizon, so using the horizon as some sort of bulge obstruction is nonsense. We don't have that. What we do have is lots of miraging effects because of foreshortening, i.e. when you look at something in the distance like a mountain, the mountain raises in elevation, and I have to give this an actual sizes, but hundreds of thousands of feet. Whereas if you're at 5 feet in elevation looking across a vast distance of water, you're only representing what is 5 feet in elevation in 50% of the frame of your picture. So in this picture on screen now, the 50% below the midpoint, the ocean, represents about 100 feet in elevation, whereas everything above the midpoint is hundreds and hundreds of feet. Now these angles aren't considered in the curve calculator, but this is what we see when we take a picture.
Anthony, actually, would you mind showing up the equation I sent you?
You really want me to show this?
Sure, go for it. At the very least, I know Nathan won't like it.
Okay. So,
if you thought you hated R before, you're not going to be happy.
Nathan, this is what Hillel sent me as. Just run us through this, Hillel. What is this?
First of all, it's hell, and it's hell to do. It's an equation for the angular size, or the visible angular size. Let me start over. I misspoke. It's the equation for the angular size of the visible amount of a target of a given height for a given height of an observer over a given distance of the globe Earth.
And is this based on science, or is this your interpretation of the science?
It's not based on science at all.
What's it based on?
It's based on math.
Oh, it's based on R.
No, it's based on math.
Sorry.
Well,
I see the words radius of Earth as height of observer.
I guess this would work for if you have any round object.
Sorry, we have a fixed radius for Earth, do we not? Don't
Sorry,
give me
could you
this
say it again?
bullshit. I'm not interested in Mick West's answer. Oh, I can change the value of R. Really? Can you change Earth's radius, Hilal?
Of course not.
So we have a fixed value of R in this calculator which will not change and is detailed. I can see it at least a dozen times.
Oh, it's in there more than a dozen times, I promise.
Right, so this is based on a presupposition of an R value that you have and it is fixed, correct?
Sure.
Right. So we would
But
need
you-
some
like I said,
so
you
we
don't
would
need-
need some scientific evidence of Earth curve before you start calculating out how much perspective affects Earth curve. So we don't have any scientific evidence of R, do we?
I disagree.
Sorry, it's a begging the question fallacy. Do you really not watch the show?
Actually, usually I don't.
Oh, right. Oh, no problem at all. You're
I
starting...
wanted to. Well, I want.
Don't worry, I can explain it. You start with the presupposition that you're on a sphere. And you, globers, have no scientific evidence for the R value. You just presuppose it with a fixed value. So you presuppose sphericity, and you have no scientific evidence. But you insert it into the mathematics like it's justifiable.
Well, you have to put it in the mathematics if you want to make any kind of predictions.
Sorry, your mathematics don't make predictions.
Yes, I do.
No, they don't. They're based on a presuppositional value of R that you have no evidence of. So it's not predicting anything. It's just some concept you've
Yeah,
invented.
it's a prediction based on a presupposition.
So that's not a prediction. It's a prediction based on presupposition, which you have no scientific evidence for. So your
Yeah, look, in
presupposition
order
needs
to make a
proving.
prediction,
Your
you have to say
presupposition
if-
needs proving first.
The prediction.
No,
needs-
it's not a prediction. It's based on a presupposition. First, you must prove your presupposition. Why is it that you are now not understanding that you can't base it on the assumption of sphericity? You don't have proof of sphericity,
How are you
and you
gonna
don't have a
calculate it?
value of R that you have measured or scientifically validated in any way, shape, or form.
Every prediction has a presupposition.
Sorry, you have a predicted cause in an independent variable, a cause of the phenomena.
I'm sorry. Can you say it again?
You have a predicted cause of the phenomena. And in a scientific proof or a scientific experiment, your independent variable is the thing that you will be manipulating, the cause of the effect.
Yes.
Well, you don't have that. You don't have scientific evidence of the presupposition. You just have an assumption that you insert there to justify your mathematics. And then when you come
how
out
else are you
with
going to make every prediction has an assumption in it. Predictions can't work without assumptions.
Yeah, but then you go forward and scientifically validate them. So yes, a hypothesis has a prediction in it, and you assume what your cause in your cause and effect is. But you don't just stop there. You then go forward and systematically experiment.
Yeah.
Right. So what's your systematic experimentation to prove the value of R?
Well, for now, it's my observation of the Isle of Man, which I'm working on.
Sorry, your observation that you're trying to use as a proof of R is your proof of R. You've got a radius from measuring Isle of Man. Is that what you're telling me?
Maybe. We'll see. I'm not
So,
done with my analysis yet.
Was this a scientific observation?
I do my best.
Do your best. Science has a method. Do you know what that method is?
Yes, I know what the scientific method is.
What's the first step?
You would say observe a phenomenon.
Right, so what's your observed phenomenon in this experimental proof of R?
The Earth exists, the Isle of Man exists.
So you're testing the cause of something existing. That's a concrete noun. That's not a phenomenon.
No, that's the first step, is observe a phenomenon.
That's not
and
a
I observe
phenomena.
that the
That's
Isle
just
of Man
something being
exists.
there. That's not a phenomena, is it?
How is that a phenomenon?
That's a concrete noun, sir. So what is your observed phenomena? You
observe
don't
something
have
or a
one.
phenomenon.
You don't have one.
I beg your pardon?
You don't have one.
It's-
You don't
the
have an
first step
observed
is
phenomenon.
observe-
You have a concrete noun. I've said it 3 times.
What?
Are you dense or
The
stupid
first
or
step
deaf?
is observe something or a phenomenon.
No, not observe something or a phenomena. You just told me that step 1 was observe a phenomenon. Now you've changed that to observe something. No, you absolute idiot.
Fine.
Not fine. You are an idiot, and it is not fine for you to tell me that you've got R when I assert that you don't have any scientific evidence of R. And you tell me that I've gone and observed the Isle of Man, that's my phenomena.
How would you
Don't reverse this. This is not my issue. You, sir, have asserted you have proof of R. You do not. You have a
didn't say that.
presuppositional value of R that you
I
assume.
said I
It's
said
a
I'm
little more
working on it.
complicated, is it? So, what's the scientific evidence of R? I don't care how complicated it is. We can take as long as you like. Don't
said I'm working
sigh.
on it.
Just give me a scientific evidence of R that you presuppose.
So, by that, you would mean that you would want a hypothesis, prediction, etc., which does not have R anywhere in that except for the conclusion.
I don't
first
care
let's
what you
start with
give
the
me. Give it
multi-nine
me
core.
and I'll scrutinise
Oh,
it.
God.
Give it me and I'll scrutinise it. You guys claim to be backed by science. Give me science.
Right, let's see this perpetuating molten core. Let's see proof of
Okay.
that.
Hold on.
Yeah,
Hold
what
on.
I
We're
was-
on R. What are you talking about?
Nathan, so what I'm
Yeah,
trying to
but-
ask, first of all, is in this scientific proof, you would want R to be nowhere except the conclusion.
I'm not laying
that
down
right?
any parameters whatsoever for you globeheads who think you live
There are
on
no
a sphere.
parameters?
No, you do what you like to give me scientific evidence of R, and I will scrutinise it. Don't ask me what you need from me. I've told you, scientific
Well,
evidence
you're saying
of
you
R.
want something from me, so I'm asking what you want.
Scientific
Is that not
evidence of
alright?
R. Repeat it back to me.
Yes, scientific evidence of R, but I'm asking...
Excellent. Now give it to me. Don't stutter. Don't dice the point. Don't tell me that you don't have a phenomena. Just give me your scientific evidence of R.
What I'm asking is...
Don't
would you-
ask me. Give me scientific evidence of R.
And listen, Nathan.
I am listening to you babble and distract from what you haven't got, which is scientific evidence of R. You're just going to ask me questions when I'm asking you. Give me your scientific evidence of
And
R.
I'm asking, am I allowed to use a calculator?
Do whatever you like.
So in this scientific proof, I'm allowed to use a calculator.
You can present it and then have me rip it to shreds in front of 200 plus people. Don't sigh. Yeah? You just present it and then watch me rip it to pieces.
Oh God, Nathan, listen.
I am listening. I'm not deaf like you. I don't have to be asked to repeat things back 4 times. I'm not deaf.
Okay.
Don't sigh. Give me your scientific evidence of R. Stop sighing. Give it to me now.
I don't have it now.
Right, you don't have it at all. Nobody has scientific evidence of R because there isn't any. You assume it because you have a religious belief. Yeah, I was waiting for the sigh.
Yeah, I'm sighing because
Yes, because you have a religious belief in an assumption of R.
So is this... What are you talking about assumptions for now?
Because you assume R.
So so people aren't allowed to use an Earth curve calculator then in their
Well, that would be a
scientific
begging the
evidence, because
question
that's an
fallacy.
assumption?
That would be a begging the question fallacy. That's my point. That's why I asked
So
Mick.
no one is allowed to use
That's
an
why
Earth
I
curve
asked.
calculator.
Shut your mouth. That's why I asked Mick the same thing. What's your scientific evidence of R, Mick? And he gave the same answer. I have to assume R. So you have a religious belief, and yes, an Earth curve calculator, shock horror, begs the question. It begs the question because, like you, because you are an idiot religious zealot, assume R. You have no scientific proof of it, and when I ask for it, you stutter, sigh, and start asking me questions. I'm not here to be answering anything to do with R. That would be like the curve calculations that beg the question also and omit perspective, your problem, not mine.
And Nathan, what I'm asking is anyone allowed to use an Earth curve calculator in this scientific proof?
An Earth curve calculator is not scientific in the slightest. Do you think... Let's rephrase that. Do you think that an Earth curve calculator with a presupposition of R and an omission of perspective is a scientific proof of anything?
No, of course not.
Right. But you guys who have got a globe belief seem to present it next to a photograph as proof of sphericity.
Yeah, I said by itself.
By itself, what? When in comparison to a photograph that includes perspective? Would that be a better proof when you compare it to something that includes perspective? Wait for the sigh.
It depends on how you use it.
Well, we use photographs with a shutter. We take the picture and voila!
No, it depends
perspective.
on how you analyze it.
We don't analyse it, you do.
You don't analyze anything.
No, you have a curve calculator that begs the question, assumes R, proves nothing, and omits perspective.
So anyway,
I just waited for the little sigh. I like the little sigh now. It's my little tell that things aren't quite sinking in.
Sure. Anyway, what I was asking.
Not anyway. Maybe it's time to get you to repeat a few things. Repeat what I've said about your calculator. What doesn't your calculator do, Hillel? Does it include perspective?
No, and it doesn't need to.
Oh, it doesn't need to. We don't really take into account perspective when we look at things and compare them to photos. We can ignore it, because that way we can pretend we've got curve. Right, Hillel?
Depending on how you analyze it, yes.
Yeah, depending on how you globeheads analyse it, you omit perspective. That's how you analyse it.
Yeah.
Yeah, don't
sure.
sigh.
I can sigh as much as I want to.
Yeah, well, every time you do, it tells my audience that you're reaching the point of despair. You've got no answer.
I believe that I am reaching a point of despair, but not for
yeah,
the reason
good.
you think.
You're a globehead with a religious belief in an R value that you assume, and you omit perspective in your calculations when you beg the question of R and tell people it's proof of curvature that in reality is just the effect of perspective. Wait for the sigh.
So actually, that actually leads into what I was going to ask you, which was about, so again, like I said, I did my Isle of Man observation, and the way I'm going to be analyzing it does actually take perspective into account.
Sorry, the perspective that you gave us in your calculations that assumes an R value?
Yes, that one.
Oh, right. Well, that is based on an assumption of R that you have no scientific evidence of?
Yeah, sure.
That's a bit of a shame, really, because you'd need to start by validating some of your values. That would
That's
be an
not how
R
that
value.
works.
Sorry, you seem to talk over me when we get to these awkward bits.
Oh, sorry.
Yeah,
Speak
that's
on.
all right. Don't worry about it. Maybe you can sigh when I get to my point rather than interrupting. So, your equation needs validation for the measurements and values. One of the values is an R value, and we have firmly established that you have no valid R value. Just an assumption.
Yes, and
So, rather than assume it, go out and prove it. The R
that's
value.
what I'm doing.
No, you're using the R value. You already assume it, don't you? You've already got it. Why do you need to use it? Why do you need to go out and find it? You've already got it, mate. You've already got an R. You've already got an R, haven't you? Have you already got an R?
What do you mean by that?
So you already have a sphere with a sphere value, a radius. You don't need to go any further. Where it says radius of Earth in your equation, there's your proof. That's it. You don't need to do anything more than that. That's what you need. The radius of Earth.
Okay, the
So
equation by itself doesn't prove anything.
We know that. Yeah? Thank you for pointing that out so succinctly. We absolutely know that the equation you give proves nothing.
Not by itself.
Yeah, that's why I call it a begging the question, proof of nothing, perspective omitting curve calculator, because it proves nothing.
Let me explain now how I will be using it.
I don't care how you're using it. All I care is how you apply perspective. Because currently you don't.
That equation does apply perspective.
It uses a radius of Earth.
Yes.
Well, you already have a radius of Earth. You don't need to go any further with this argument. Just show me where you got that radius of Earth from.
The standard model?
So it's an assumed value, same as McWest then?
Sure.
Right, that's not acceptable. You don't just assume that you're on a sphere automatically. That's not what we do. That's called a logical fallacy. The logical fallacy known as begging the question. Please repeat back to me. Please repeat back what I've just said.
Can I explain now how I'll actually use it?
No.
Karen B had it there.
Repeat back what I've just said. What type of fallacy assumes your outcome, Hillel?
It's not assuming an outcome.
So you don't already have a sphere with a radius then?
No, we do, but that's not...
Right, so that would be assuming your outcome, you absolute spastic. What part of this don't you get? You are assuming you have a sphere, you are assuming it has a radius, and you have a number for both. So you have a radius of a sphere with a value, and you're telling me that doesn't assume the outcome.
No, it assumes a possibility.
No, it doesn't assume a possibility because you're going to move forward and confirm your presupposition. That's called a fallacy. In this instance, the begging the question fallacy.
Nathan, would you let Karen ask that question again?
Go ahead.
My question to you, Hillel, is how do you use an assumed value to prove the value itself? Because that's what you're
By
saying.
testing it.
Okay.
So for example, as I've been trying to say, the way I'm going to use that equation that I showed you is by applying it to the images that I took and to see if it works. And if it works, then that proves the values in it.
No,
okay.
it doesn't.
Well, you know, we've been doing this already for a very long time and it doesn't match.
Well, sure, then I'll see that for myself when I do it.
Okay,
Yeah, but
good.
the thing is, in Taboo Conspiracy's video, he showed that with two mountains, Mount Blanc and Mount something else, he showed that over a long distance, that the two calculators, be it flat and spherical, the Metabunk one, they both appeared to support the same conclusion. Yet one of them must be wrong. So what his point was not that they're both right. The point was that the Metabunk one appears to be giving a representative mathematical position, but it can't do that if the plane maths also do the same thing. So in other words, there must be something wrong somewhere in the maths with the Metabunk because it can't support it being flat with the flat maths if it's supposed to be a sphere.
And with that, I'm going to say first and foremost, a huge, massive, enormous thank you to all of the live audience for tuning in and hopefully for sharing this debate. And of course, a massive thank you to all of the debating panel for making this debate possible. If you hated the show, you know exactly what to do already. But if you like the show, maybe consider sharing it with a friend or subscribing if you have not done so already. I've been Nathan Oakley, and I will see you all in the next video.
Oh, what a day! What a lovely day!